Hello all and welcome to our first talk. Thank you very much, Pietro, for being our experimentation subject for the first time ever.
Thank you, Max.
So we have a great talk. It's from Hardware to Zero Day, and it's Pietro Oliva who's going to be giving us this talk. Thank you, and please proceed.
Hi, everyone, and welcome to my presentation called From Hardware to Zero Day, or basically how I bought a camera and never used it for what it was supposed to do. So before we start into the details, let's talk about who I am. So I am Pietro Oliva, and that's my Twitter handle. And I'm a security researcher currently at R3. I was previously working for Sony, JP Morgan, and other companies of security roles. And before we even begin, just want to clarify that none of this research has anything to do with my current or previous employers. It's just a personal project that I made myself. So let's get started. First of all, why would we even perform security research on a camera? I mean, what's interesting about it? And afterwards, I started looking what's the current state of the work on this camera. So what's been done before? And then I faced myself with a challenge. I chose to have this challenge. And then with various steps, I achieved some success to reach my goal. And then I will talk about some lessons learned from this process. And then what was initially my to-do list and future work that you can also feel free to continue yourself. And then we'll talk about conclusions and Q&A. So the first question, why would we even start doing research on a security camera? So the question I ask myself is, many people say audio devices are insecure, and is that really true? Can I verify this claim myself? And apart from that, I was looking myself for a challenge and a learning opportunity. So I wanted to get something out of it. So let's look a little bit into the previous work of the security camera. This is the camera that I bought myself for this purpose. And there was some command injection vulnerability at the time I bought it. And apparently there was nothing else. So I asked myself, is there really only one vulnerability for this camera? And then that's when I started with my challenge. And I decided that I want to hack the latest and greatest firmware, regardless of the previous findings, right? So I wanted to do this in a particular way because I wanted to learn. So I started from the hardware itself and dumping the firmware myself in order to analyze it with some reverse engineering tool, because I wanted to learn MIPS assembly and architecture. So that's what I started doing, and I wanted to look for a tool that I could use everywhere for casual hacking on the go. And I found a tool which is Radar 2, which, by the way, can be used in a mobile phone or tablet. So if you have an Android device, for example, you can install it and use it. So how did I do this hardware analysis and flash dumping? So I simply took pictures of the board. This is the main board that you can see in these pictures. And I also looked up the FCC ID of the device that is found in one of the labels in the package. And you can see, for example, the picture on the right is taken from the FCC website. And you can see here the processor, MediaTek, and if you zoom in, you can see even the exact model and everything. And this is the RAM, and then we can find the main components. Once identified the main components, such as the SPI flash, I basically proceeded to dump them to see what were the contents. So in order to do that, I used this tool called BusPirate, which is the board you can see in the background of the slide. And I use FlashROM to interface with this BusPirate because it acts like a serial port. And through that interface, you can issue commands that goes to the SPI chip. And I figured out once I took the dump that the 8 megabytes, sorry, SPI flash contain the main firmware. So I started analyzing it. How do we analyze this firmware? So I chose these tools. You can use others, certainly. So I use Binwalk and Jefferson to extract the main firmware. So Binwalk is to extract the main components that make the raw image, and then Jefferson to extract the Jefferson file system. And then I use that Radar as the main reverse engineering tool. And I focus mainly on a binary called IP camera, which implements all the main functionality of the camera. So once we start looking into this, let's see what are the vulnerabilities that I found. So this is the first one. So as you can see, this is a login method. This is what it's doing is it's taking the user and password and matching them to see if there is a valid login provided by the user. And then if it's not valid, then it just keeps an entire piece of code. Otherwise, it just goes ahead and grabs the HTTP user agent header, and then it looks for the Firefox string. Now, what this code was supposed to do was to check if you were logging in with a certain browser. There were also Chrome and others. And depending on that, it will do certain actions, customized depending on the browser. Now, if you look closely, you will notice that when it's getting the user agent string in here, in this B0, and this B0 actually could be null, because if you don't send any HTTP user agent header, this header will just not exist. So this pointer will be null. And when you call strstr, at that point, you will get a null pointer to reference, and it will crash the main process. So crashing this IP camera means you cannot longer access the web UI, because that's the main binary that manages all of it. So this was the first bug I disclosed to TP-Link, which is the vendor. And I post here a quick summary of the timeline. So the way it started was that they claimed the camera was not supported anymore. And after that, I decided to see if other cameras were affected. And I could confirm that, even though I didn't have all of them, because I could go to the website, download all the firmware images, and reverse engineer them. And I confirmed, and I warned the vendor that all of them were affected by the same vulnerability. So in March, at the end of March, I dropped this as a 0-day, because the vendors will still not fix the issue, will not be responsive, and will not seem to be keen to fix this issue. So I decided that I will just drop it as a 0-day. And suddenly, after roughly a week, they fixed it. So they did care about this, but they just didn't really want to do it without a 0-day out. So after I did that, all the next reports were taken way more seriously, and the deadlines were kind of respected. And after that, I promised that I won't report any more issues, because it was not very pleasant, certainly. And I mean, let's say I was basically asked, can you please confirm this is the last issue you are going to report us? So I said, yes, I won't do it anymore. Right, so let's talk about other issues that I found, interesting ones. So this is a Stack Overflow. The way it works is there is a routine called del multi-user. This del multi-user, what it does is exactly what it says, which means it goes through a list of users, which is a comma-separated list of users, and then basically calls this delete user method, and then stores the error code in a stack variable, which is here in the frame pointer. Now, the thing is, since this accepts a list of usernames, if your list is long enough, it means it will get a very huge list of error code strings that get concatenated. So, of course, since the destination buffer is on the stack, this means that you are effectively introducing a stack buffer overflow. The only problem with that is that you cannot really control too much, because the only thing that changes between those strings is the error code itself. So depending on whether the user exists or not, or if it's yourself, and things like that. So if you were wondering what the proof of concept looks like, it's something like this. In the HTTP request, you will just send username equals a bunch of commas, and that will be enough to render your camera basically unusable. Now let's talk about the next bug. This one is a bit more interesting. So it doesn't look really hard to understand what's going on here. It's taking a backup from this location, and it's taking a string TP-link and it's passing it to a function called desencrypt with this ebackup string. So what we understand from this is that it's taking this backup, it's encrypting it with this key, and then with the des algorithm, and then it's storing it into the encrypted backup. That looks easy, right? But there was a problem. I mean, after I tried to decrypt these config files that you could download from the web UI, I could still not decrypt it because I will see random characters, and I couldn't understand what was going on. So I knew the algorithm because it was DES. It was ECB mode. You could see from the patterns in the encrypted format that you see some repetitions. So I found a tool on the internet that will correctly encrypt and decrypt it. But if I tried any sort of standard DES implementation, I could not decrypt it. And I couldn't understand why. And I thought I was doing something wrong myself. And then I realized that you don't just use an encryption key, or at least that's not what they did. What they did is, after checking all the code, I went ahead and checked the permutation tables. And if you compare the screenshot on the left and the screenshot on the right, you can see that these tables differ slightly, actually by 1 unit for each of these values. Now, this is not only true for the initial permutation table, but for all of the constants of the DES algorithm. So what they did was to change all of the constants everywhere, not just this initial permutation table. And that's why I could not decrypt it. So this must be the default process that was behind it. So you could have chosen to use a strong encryption algorithm, but instead they decided to customize a weak one. Now, once we decrypt this file, let's figure out what's inside it. What's the structure of this file? So we can see there is a small header that tells you what is the file size with there is a magic, and then the MD5. Then there is this null terminated string fingerprint, and then some padding. And then start the file entries. Sorry. And we have very simple format. We have 4 bytes for the absolute offset of the file content, file size, again, some padding, and then null terminated file name. And that's it. And then at the end, you will see also the content, but the screenshot is not big enough to appreciate that. So what we see from this is that this contains effectively file names and file contents. So this could probably give us an arbitrary file write. And we're going to see it shortly if that's true or not. All right, so I made this little script, and what it does is it creates a config file, and then it embeds in this config file these demo1 and demo2 HTML files, and then it encrypts it, right, in a format that can be understood. So if we execute this and then go to the web UI, now we should be able to just restore this config backup. So it's here and restore. Now the camera is going to reboot because, of course, there could be changes that need device reboot. Of course, it's not our case, but that's just the way it was programmed. So we'll have to wait until the camera comes back to us. In the meantime, I will set up the network. Right, so we're back into the UI. Cool. So let's see if we have successfully uploaded this demo1 and demo2 HTML files. Oh, look, now we can play Doom on this camera instead of the camera frame. What we can see is just launching this game just as a proof of concept to show that we can effectively write files everywhere, play Doom or whatever we like. Could even replace it with some, I don't know, some image, some static image, if you want to give the illusion that the camera is being used, but it's actually frozen. But also, what's interesting is that we could go ahead and, I mean, I don't know if you noticed, but if you go here, it says that you need to install a plugin to watch the stream. This is ridiculous because it's 2020. So I went ahead and say, can I actually make this better? And this was the result. So as you can see, now I can see the live stream of my camera without any plugins that I will not trust anyway from this company, and it just works. Now let's go back to the presentation. Go ahead with the next topic. So this was great. This gives us arbitrary file write, and I wanted to find some other issue, like for example this one. This one is specific to the NC 260 and 450 models, and what it does is just literally takes an encryption key from an argument in the HTTP request, and then just tries to store it in this encrypt key directory. Now, the way it does it is it's actually doing some echo of your string, and it's passing it into this CM command. CM command is just a wrapper to system. So effectively, this gives us command injection. And if you were wondering, these commands are being executed as root. So this was great, but it only affected these two models. So let's see if we can do even better than that. And this is where it comes this next bug. So as we can see here, there is this CM command again, which is a good sign, right? We know it's system. And if you go backwards, we can see this command, MDNS responder POSIX, and then there is some parameter here, which is a string. And if you look at this string, it should be this V0, which is in A1. And if you go backwards again, V0 comes from this FP20, the frame pointer plus 20. And if you go backwards again, we can see that it comes from this bonjour get name, because it's one of the arguments, right? It's V0. So that means this is getting a name from somewhere, and then this name gets put into this MDRS responder command and then just executed. The thing is, can we control this name? Let's look at this system set product alias check, which is the method that actually is called exactly before setting the name. And we can see that the only real check that is happening here is this call to strlen. So they're indeed doing some checking in this routine, but they are only checking for the length of the string. So as long as your string is shorter than this 0x81, your string will just be unfiltered and be part of the command line. Now, this is true for all cameras except the NC210, which has this filter implemented correctly, but not this one in the bonjour.http. And we can see how we can exploit that. And this is basically what the thought process must have been in this moment when they checked for the length without checking anything else. So this bug, we know it affects all the cameras and can be triggered easily, and it gives us a reliable root shell. Let's see if that's true and if it's working. So we got here these. Okay, here's the terminal. So what we have here is this little script. We are generating a payload with MSF Venom. Nothing fancy about it. Now, what we do here is creating a config file again, so we can exploit the issue without going through the first check. So we are combining effectively the hard-coded encryption key issue with the command injection issue. So the way we are doing it is we are uploading a system.conf file that looks exactly like this. And then, as you can see, the command injection is here, and then it's executing this etcs. Now this etcs, as you can see, is getting uploaded here, and it's this payload.alpha that we just generated. So we are uploading two files, the payload itself and the command injection here in the system.conf file. So let's see how that works. We execute this. So effectively, we are creating these files, and now it will start the Metasploit framework. Now I have this QEMU running here, which is simulating this NC210 camera. And now all I have to do is to go to management, browse, go to this, where is it? systemconf.cfg, and just restore. Now again, this is going to reboot the virtual device, which is in this QEMU thing. So I'll just skip through it for a moment. I'll just leave it there, let it reboot because it's going to take a while. And let's go ahead with the demo number 3. Now for the other cameras, which are a bit more vulnerable because they have missing checks on both methods, you can exploit them directly with this Metasploit module that I made. And by the way, it's also public, so you can freely download it and use it. It's part of the Metasploit framework on GitHub. So all it's doing is setting the remote host, port, username and password from the web UI, and then just the payload that you want and where you want to receive the shell. So let's see how it goes. This is the NC200 device, which is the one that I showed you before. And this is the same thing, but for NC450 camera, which is another one that I have in QEMU. So hopefully this is not too much to ask for my laptop. And so this is still rebooting. This one, I don't know what's going on. Yes, it's running. Okay, so we can see in the NC200 camera, we have a shell opened, and we can clearly see that we are on this user local that's been path, and we can list the process, and we can see this MDNS responder POSIX, and we can see the command injection like clearly. Now, the same thing is valid here. We can see in the NC450 camera, which is also this emulated with QEMU, we can get a shell, and we are root. So that's great. And let's check the demo number 2. So we have here, this camera is rebooted. So I'm going to simulate the reboot with this start SH. It's not doing anything fancy apart from starting the HTTP server, right? So we're going to start it, and then there you go. Basically, when it starts the MDNS responder process, it will get this command injection there, and we get a shell. So, okay. Let's go back to the slides. So what did we learn from this? So we can see that there's a lot of code reuse, right? Because all these cameras were very similar indeed. And that means that the same vulnerabilities affected them. And another lesson is that dropping 0 days is not necessarily a bad thing if it helps fixing issues. Please give time to vendors to fix their products, but if they're not responsive and they don't do anything about it, then maybe this is the little pressure that they need to go ahead and fix stuff. And also another thing that I learned is that reverse engineering can reveal bugs that cannot be found via fuzzing or black box testing. Why is that? Because this bonjour command injection thing could not be exploited like automatically, because you could not see anywhere where you could set a device name in the web UI, but there was this URL that you could just, if you knew it, you could send a request, and at that point you will trigger the command injection. So it's not good to do only fuzzing or only black box testing or only reverse engineering. It's good to do both. Now, future work. This was initially my to-do list. You can, guys, take this research and continue it if you really want to. For example, you could look at vulnerability that can be exploited from the TP-Link cloud, or the browser plugin, or basement vulnerabilities. Conclusions. So indeed, there was more than one vulnerability affecting these cameras, and you don't need any expensive tools. You can just use radar, and you can even be on a mobile phone on a plane. Actually, I didn't show this before, but if you look at the screenshot, you can clearly see that it's taken in a mobile phone. This is Thermux, and this is radar, and you can see I was in flight mode. So you can even do this on a plane. It's amazing. Without any preparation, you don't need to have any tools, any special tools to bring with you. So this is what you can do. And as we said before, this is necessary to complement your testing. And it was indeed a very good idea to never connect this camera and never use it. And I can now say for real, from my experience, that some IoT devices indeed are insecure. And another thing that I wanted to reinforce is that security researchers and vendors have a shared responsibility. It's not just the vendors, it's not just the researchers, but it's the collaboration between them that enables devices to become more secure. And that's all. Thank you very much for listening. Have you got any questions?
So that's great. Thanks a lot. I think people really enjoyed the Doom running on the security cameras. That was fantastic.
Everybody loves Doom.
I'm just quickly checking to see if any questions have been relayed up. So far, no questions. Let me just go back to the training channel and see what else. Nope, no questions. Just comments. So they've really enjoyed the talk. And I want to thank you very much. So there is the Discord channel if you do have questions. Sorry, a question just came in. It said, when you said you wouldn't continue research, the question is,
yes.
Why not?
I wouldn't because, as I said, it wasn't super pleasant. As I said, there was a slide called The Pain of Responsible Disclosure. So if you want to do this responsibly, then there can be a bit of pain there because the vendor is not always responsive, and not always it's pleasant. Of course, it can be rewarding if you manage to get something out of it, but yeah, I will not continue it myself because I had to promise it. They said literally, like, we pushed 2 updates in the past 2 months. Can you please stop? Basically. So that's why I said, okay, fine, I'll stop it. Okay.
Yeah, no, it's understandable. If you don't have a willing participant, that makes it difficult. And another question came in, says one of your objectives was to learn MIPS.
Yes.
You seem to have picked it up very well. Do you have any resources that you can share as to what helped you through that?
Well, what I did was to just look at the MIPS manuals that you can find online. There are plenty of them. Just go through the list of instructions and basically just compare them with your disassembly. And also I recommend you to check with some decompilers, because I wanted to learn MIPS and that was it. But if you want to speed it up a bit, you can also use a decompiler. So you can look at the same time what it looks like in a decompiled form and what it looks like in assembly form. So you can also cross-check your knowledge and always go back to the manuals. And there are also some instructions, some commands in Radar that you can use to describe the instructions that you're reading. So you can, it will say, like, I don't know, moving this value to this register and things like that. So these things really help a lot.
Okay, great. Another question is, did they patch the unsupported camera or just the newer ones?
Yeah, they patched all of them.
That's great.
And actually, yes, that's why I could make this presentation, right? I didn't feel like dropping all the 0 days everywhere. But there is one good thing. I mean, one good depends on which side you look from. The hard-coded encryption key, for example, the way they fix it is that they generate a random key for each camera, right? And now, if you think about it, this means that they are using DES in ECB mode and everything. So if you want to, because you know also the file format, so you have a known plaintext attack you could do. You could do some brute force, for example, because you could guess what's the plaintext, and you could recover this key. And if you can recover this key, then you could craft your backup file, and you could still exploit the same vulnerability as if it was hard-coded, because you can effectively break this, which is too weak, which is, by the way, something that I told them, and they said that it would be too much architectural change to make this happen. So that's something that they're not going to fix.
Thanks for sharing that. I'm sure that's another path for somebody else to explore.
Yep.
As far as the response that you received back from D-Link through this, did they pressure you to stop exploring further in this?
Let's say that I could feel that my reports were not necessarily too welcome. So,
sure, they're not appreciated. I understand completely.
Yes.
You know, you don't want to keep pouring in your efforts if someone's going to resist change. I understand that.
Also there's another reason, right? I mean, I want to go ahead with my life as well. I mean, these cameras are nice to play with, but I had other projects as well that I want to get into.
Cool. Do you have any of those that you care to share at this point?
Not yet, because I have many in mind, so I have to still focus and decide which one I want.
No problem. No problem. Do you mind if I have another question that came up? What steps can clients do to minimize the attack surface based on the vulnerabilities you found? And do you think that...
I would say limit the access to the web interface for sure. And the first thing would be do not use unsupported devices, right? I mean, and if you're buying a camera, don't buy a cheap 20 euros one. Just get something that looks a bit more reasonable. And also, I will say restrict access to everything you can. So, for example, access to the web UI, don't expose that port to the internet. That would be stupid. Or if you're in a corporate network, firewall the ports and just allow authorized traffic. For example, only the admin should be able to manage these things. There is no reason why somebody would access the web interface of these devices or other services.
This seems to be geared more for home consumers than anything else.
Yes, yes.
Do you think network isolation could be a very effective?
Well, yes. If you can't reach something, you cannot hack it. Or at least it's going to be much harder if you cannot poke with something. You cannot reach it.
So yeah, I want to thank you for giving the first talk and helping us shake out all the bugs. It was a wonderful talk. It was very well appreciated from the community. Lots of people congratulating. If you want to shift over to the Discord while we wait for our next talk to happen.
Okay. Thank you very much, guys.
Yeah, thanks a lot.
Thanks, everyone. Thanks, Max.